Welcome to Ecogradia, where we meet experts and practitioners at the front lines of sustainable architecture and urbanism. My name is Nirmal Krishnani. I'm a sustainable design strategist, author, and educator based in Singapore. Today is the fourth webinar in a limited series organized in collaboration with the Holcim Foundation for Sustainable Construction. Now, this series provides a unique opportunity to peek into the projects that came out on top in the Holcim Awards 2023, which ended in Venice last November. We get to hear from two award winners about the making of their winning entries and find out how sustainability is pursued in their part of the world. I'm pleased to have with me today representatives of the teams that won the Bronze Awards for North America and Asia Pacific. Ryan Bussard is with the Seattle team that led the design of the Kaiser Borsari Hall, a 5,000 square meter facility for the Western Washington University campus, which will be a zero energy, zero carbon building when it opens. Erik is with the Singapore team that won the retrofit of the NUS Yusof Ishak House, a social and cultural hub on the campus of the National University of Singapore. It too strives for deep targets in energy and carbon. This webinar series is sponsored by the Holcim Foundation for Sustainable Construction. The foundation was created in 2003 to empower a community of future makers through the transfer of ideas, knowledge, and real-world solutions. The Holcim Foundation today delivers on all these fronts with a treasure trove of information on its website. You can find all past winners of the Holcim Awards from all over the world and discover the strategies they followed on their journey towards sustainability. Go to holcimfoundation.org to find out more. Welcome, guys. Ryan, it's a great pleasure to meet you. Congratulations on winning the Holcim Award last year. And Erik, full disclosure, you and I are colleagues at the same university in Singapore. In fact, the topic of this webinar is a continuation of a conversation that we've been having for several years now in the course of other projects on the same campus. You may remember this, Erik, but the phrase that kept coming up on the zero energy building that you and I were working on was what we, universities as places of higher learning, have to do. We have to walk the talk. Campus buildings must rise to the challenge of our time. And today, walking the talk means setting and meeting climate targets and framing aspirations for well-being and inclusivity. So in the coming hour, let's discuss how this is done in both your respective projects. But first, a little background. So Ryan, you're an architect, a design principal at Perkins&Will in Seattle in the US. The jury for North America in awarding your team a bronze had this to say about the Kaiser Borsari Hall. And I quote an excerpt. The project team demonstrated a comprehensive and well-thought-out approach to infrastructure design, considering both functionality and sustainability. It is particularly successful for its ability to push boundaries, especially in the integration of engineering systems and a significant amount of energy storage. Erik, you were lead designer on the project. You're also a full-time member of the teaching faculty at the National University of Singapore. The jury awarded the team the bronze for the Asia Pacific region. Now, here's an excerpt from the jury comments. I quote, "The NUS Yusof Ishak House is a bold refurbishment project, taking the building from fully air-conditioned to passively ventilated spaces. The jury noted the project's exceptional design, which harmoniously integrates with and responds to the tropical landscape. Julie highly regarded the project's outstanding demonstration of how to repurpose and retrofit conserved buildings." I'd like to hear this from you in your own words. Before we start the conversation, could you walk me through your project? Let's start with you, Ryan.
Great, thank you. So we're excited to talk about Kaiser Borsari Hall. It is a new 54,000 square foot mass timber project that we're designing for Western Washington University, located here in the Pacific Northwest region of the United States. This new building is very exciting in terms of bringing together from multiple locations on the campus into one new building, the Institute for Energy Studies, which is, I think, very appropriate for our discussion today, as well as elements of the electrical engineering and computer science programs. The new four-story building utilizes a mass timber structural system and is conceived as a simple yet elegant massing clad in shosogiban wood that wraps the entire building. As you can see some of the images on the screen, the cladding is strategically interrupted by very small amounts of glazing, tuned to around 34% of the vertical surface area, but still allowing us to illuminate 90% of the spaces within the building. The roof is filled with the ballasted photovoltaic array, which is our main energy generation on site. With that producing over 25% on-site directly, coupled with the on-site battery system, energy storage system that we have on the project. Over 105% of the energy use is produced through renewables on-site or off-site, and is coupled with 8% reduction in the energy use over a typical lab EUI. We utilize a fully electrical mechanical system, and these various strategies and systems allow us to achieve net zero energy. We also thought a lot about the population, the students, the faculty that will be using the project. 2/3 of the building is dedicated to labs, which is unusual to think about the energy performance traditional labs. But we also thought to carve out spaces for historically underrepresented populations on campus. So we've converted over 20% of the program into a number of those key programs, including informal collaboration and learning spaces, a new multicultural lounge, and a new learning commons, which will accommodate and support the learning styles of all students with a specific focus on neurodiversity. This building, when completed this September, it's under construction currently, so we're excited to see it complete. It will be one of the first publicly funded net zero energy, net zero carbon mass timber higher education buildings in the state of Washington.
Wonderful. Thank you, Ryan. Erik, your turn. Would you summarize your project, please?
Thank you, Nirmal. The Yusof Ishak House was named after Singapore's first president and is part of the National University of Singapore's campus plan, and that was built in the late 1970s. The 15,000 square meter building has historically been a student center serving all the faculties on our campus, and it's situated on a relatively hilly, jungle-like terrain. The core principles of adaptive reuse include amplifying the building's architectural language while championing net zero energy and decarbonization with its structural frame being retained. Architecturally, a series of fluted precast panels extend the horizontal banding of the original structure. A new brise soleil and sunscreen improves the solar shading performance of the envelope, while the original, and I would say iconic, 6 vaulted arches are amplified and enlarged, even elongated, creating climactic straws that draw in the equatorial air deep into the building's floor plate and create generous, naturally ventilated spaces for students and faculty alike. Energy-efficient measures include smart control technologies, a very large photovoltaic array on the roof, and an innovative hybrid cooling system, helping the building to be the first conserved heritage building on the campus to achieve net zero energy targets. Hybrid comfort systems are strategically deployed throughout the building, and natural ventilation is incorporated extensively. The little air conditioning that is used is done so sparingly, almost as a kind of acupuncture, only where it's absolutely needed. With extensive reuse of the existing concrete structure, the renovated building has a low embodied carbon footprint, estimated to be less than 25% of new comparable buildings in Singapore. It's great to be part of this exciting transformational project. We hope to be finished sometime in early 2025, and I'm delighted to be here. So thanks again.
Thank you, Erik. So there are a couple of standout differences between the two projects. The Kaiser Borsari Hall is purpose-built. Yusof Ishak Hall is a retrofit. And the former is in a temperate climate, and the latter in a tropical setting. But there are, however, also several key similarities. And here's one. They both aspire to be net zero energy. Yeah. So let's unpack this. What is a net zero energy building? Erik, I'm going to put you in a spot. Could you quickly summarize what this term means?
Of course, there's many definitions, and people talk about it kind of loosely, right? We're all like kind of laughing or giggling because of that. But the way that we try to define it here at NUS is that all of the energy that is required to operate the building is produced on site. So there's no carbon offsetting or there's no energy offset. So we use all of the roofs of our building on the site of the building itself to produce all of that energy and to deliver a net zero target. So all of the plug loads, all of the air conditioning systems, all of the lighting are all being paid off, as we would say, off the PV energy on the roof.
Right, right. So it's a way of saying that the building produces what it needs, but over the course of 1 year. So it's 1 calendar year, right? And this is because there are periods when it produces more than it needs, and there are periods when it takes from the grid, but averaged out over 1 calendar year, it adds up to 0 or less than 0.
Yeah, I think that's an important point, that we do look at it over 1 year, as you mentioned, and it's an average, and we're tracking all of that all the time. It's important that, this is a planned net zero. So we'll see after 1 calendar year of use whether we've achieved that target. Hopefully we're running positive, like we've done on other projects on the campus.
Right. And so, and key to what's done in Singapore is that it's connected to the grid, and therefore the grid becomes the battery, as it were, taking and giving energy according to the fluctuations of demand. In the case of the Kaiser Borsari, there is energy storage. Actually, I want to come to that in a minute, because that's a really important, interesting part of your project. Yeah, but let's keep talking a little bit about how a net zero energy differs from a conventional high-performing building. Tell me how we deliver a net zero energy building in terms of process. Is the process the same as a conventional high-performing building, Ryan?
I think it's interesting. I think from a process of thinking about working with our clients, in the campus leadership, it is a little bit different. We think about alignment around their goals and the vision for the campus. Our client had luckily signed the Okanagan Charter and had other kind of principles in place that really allowed them to be visionary about the project. The second component was partially the funding for the project was also dependent on hitting certain targets. So we had a number of donors, private donors, who were interested in really pushing the envelope and using the building as a instructional tool and a learning tool to not only show the students, but also show the university how they could achieve these new goals. And then from there, we also, the way we structure workshops, eco-charrettes, the kind of softer aspects of the project are really centered around, once again, looking at the overall vision and goals and having that help be kind of our guiding star, kind of guiding principle throughout the process.
Right. I mean, a lot of people don't know this, but to get to net zero energy, you really have to have very deep cuts in demand.
We do.
It's not a simple question of sort of slapping solar PV on the roof just to meet whatever consumption needs there are. I mean, Erik, how much better is Yusof Ishak than a conventional building? Could you give me a number on that?
I would say that, off the NUS campus, clearly we're running zero, but we're running about 50 kilowatt hour per meter squared per year. A conventional building is around 200 to 300 here on campus. So, we're significantly less because, just as you said, we're shifting, we're cutting demand, which is really, to do a net zero energy, I think, to do a net zero energy building, I think it's also shifting culture. I think that's an important takeaway, that you have to get buy-in from not only the people who are funding the buildings, the people who are managing the buildings or even designing the buildings, but you're also shifting the culture of the people who are using them. That doesn't mean that it's painful, but it just means a little shift of expectation. And I think that's an important thing that, we've had some success, as you know, slowly building that cultural shift to occur over many buildings. Now being YIH or Yusof Ishak House, we've kind of built on those histories that helped shift and transform the culture here. Right.
To go from 200 to 40, that's not just about equipment. It's about the way the building is used as well. But just coming back to the question of how we structure the process, Ryan, who needs to be at the table that usually isn't there?
I think, I would say most of the team members are there. The difference is in the sequence in which they arrive, right? So we would traditionally build build out our kind of schedule and the process, you may have meeting with the facilities group, the people who are going to operate the building later in the process when the systems have been selected. A lot of these systems are fairly new. We're trying to literally push the envelope in some ways. So bringing them on board earlier to have comfort around that and kind of co-design the building with them is an important aspect. I think also, the idea that we're also bringing our engineers and our kind of, our modelers and people up early into the process and at the very first steps within this is also something where, traditionally that would be later in the sequence of operations, but having that group together. And then once again, having the campus leadership and the visionaries kind of who are kind of setting the performance criteria and the ideas around the building, having them involved throughout the process, not just at the beginning, kind of kickoff meeting is critical.
Was there somebody at the table that you wouldn't have otherwise had in a more conventional design process?
I think there are certain specialists that we brought in, that were driven by this. I'm thinking, and this is more on the carbon side, but we had to adapt a series of tools and modeling tools to analyze carbon that we normally you may not have in the process, right? We do that as part of our kind of our own internal check, but on the contractor side, kind of the builder side, right? They are bringing their own kind of modelers to look at the carbon question within this. So I think, having the kind of a deeper research component across all the trades is something unusual and something hopefully new and becomes part of the current practice as we continue to build.
A couple of words you used that kind of stood out for me, the idea of co-design and the idea of collaboration, that it shifts the onus from the kind of, the architect as author to a much more collaborative process. Erik, you teach design. So I'm going to throw this at you. What does this type of process then say about the role of the architect?
Well, I think it's important that co-design is there, and I think co-design means that all of the consultants, all of the kind of stakeholders are there at the table from the very beginning. Ryan was just saying sometimes they come in a little bit later, but if we can nudge that to happen, the earlier, the better. But that doesn't always necessarily lead to great outcomes. Sometimes it does, sometimes it doesn't. And what's interesting about the YAH process was that the building was kind of preliminarily designed by an architect here, part of the campus team. And they kind of reached a point of frustration where they weren't getting the kind of targets they wanted. They weren't really getting the kind of architectural expression that they wanted. And actually, it was the president who had the foresight to say, hey, wait a second, something's not happening right in the process. And, I should say I'm honored that he kind of ringed me up and said, get your team together. And I think because I'm also part of the university, I'm able to push in a way that wouldn't be so easily done for somebody outside. And so we spent 3 months kind of retooling the entire process, getting everyone on, looking at what are the key aspects, getting net zero back onto the table. Let's improve the architectural quality and really drive it so that everything came together in a tighter fit. So co-creation is wonderful, but I still believe in that you still need some drivers of that conversation. And often it's the architect who is able to synthesize and to kind of manage all of the sometimes competing, sometimes aligned voices. So as a teacher of design, I still believe in some authorship. I haven't given it all away yet.
Fair enough. But it does indirectly speak to the difficulty of certain types of clients. I mean, the project that you did, Erik, was a kind of a inside job, if you will, where it kind of
sometimes I call myself the cleaner. I have to clean up the mess.
But Ryan, you came in as a consultant to a university. I have a question for you. Are universities difficult clients? I mean, I remember my consultants when I was leading the zero energy building at my faculty saying that, coming in for a charrette was terrifying because there were 50 PhDs around the table.
Sure.
What was your experience like, Ryan?
Yeah, I think I think they're demanding clients, and they are clients that like to challenge ourselves. And there are the PhDs, and there are the intimidating groups within the room. But I think because of that, you end up with a really interesting process, right? And you end up with something where you challenge each other. And I think it brings out the best. It's like the Olympics, right? Or you know, the better the competition, the more rigorous, the kind of analytics. I think you end up with kind of more interesting projects in that regard. And I do think, you know, there's also the chance, I think, that they also bring an expertise and a thought process that might be outside the boundaries of what we may, or our consultants or our kind of trade partners may have experience with, so that it's not just a one-way street, that there could be something that comes from the client side, which is new and innovative beyond just the vision, right? That really allows us to push the envelope for that. I mean, in particular, the program, you know, one of the programs within this building is the kind of an undergraduate program for energy studies. I mean, how fantastic is that? Is to have that within a net zero building. And back to something Erik was talking about early on, you know, the building, you know, also has to reciprocate as a teaching tool in itself, not just houses teaching, but as a teaching tool back to the community and to the students.
I'm going to ask you that question in a minute about how exactly buildings become teaching tools, but let's talk a little bit about energy and net zero energy as an outcome. And we know that this depends on many factors. What are the low-hanging fruits in a campus building, Ryan?
I think, you know, I think Erik kind of started to touch on this a little bit. I think we can talk a little bit about the performance of the systems. You know, what is the comfort criteria of this? Are there spaces where we can be a little bit more tempered in terms of those conditions? The student lounge space, the open kind of communication, kind of corridor spaces. You know, can we start to think about programs where we could start to challenge kind of the way we think of the comfort criteria? I think also because these buildings are purpose-built, right? We can really dial in the use and the energy performance of those together, right? Versus something that's speculative. I think also, you know, these buildings in terms of low-hanging fruit, you know, there is a desire and there's a mandate, which is interesting, at least for Washington State, in terms of the economics of the project, where they support a certain level of performance of the building. So the project is incentivized and required in many ways to achieve that. And then one of the things that we were most proud of on our project is actually being able to restructure kind of the economics around that, from being requiring a LEED silver or LEED gold mandate to actually allow us to have net zero energy or net zero carbon, or both, be the pillars in which the funding could be based. So I think economics, which we don't talk a lot about in projects, can be a driver in terms of forcing, maybe it's not the low hanging fruit, but forcing us to start to look at other fruit within the project.
It's a thing that, you know, I talked about energy targets earlier. A lot of people aren't aware of this, but you tend to, when we are looking at certification, you know, a platinum building will typically require you to achieve 30, maybe 40% better than baseline. But a zero energy building often goes as high as 60, 70%. And to get to 60, 70%, you really have to have a very astute understanding of demand. Erik, what were the low-hanging fruits with your project?
Yeah, I mean, I think maybe a little different than, you know, Ryan's project is, I mean, as you noted, Nirmal, we're on the tropics, we're on the equator. And the climate in some ways is more consistent, and maybe we could say a little bit more forgiving. So we can afford to have a lot more naturally ventilated spaces. So that's an easy one. And as I mentioned, just to minimize air conditioning and to just put it just into those few places where it's really needed. That's the first thing. The second, as I noted, we use a hybrid comfort system, which you know very well, Nirmal, which we've deployed now on already 3 buildings on campus. So we've already got some traction, and that system is really operating at a much higher temperature than probably people from the global north would be used to. It's 27 degrees, it's almost 80 degrees Fahrenheit, and it's using fans, there's one above my head here, spinning, to elevate the airspeed, and that actually provides the comfort. So we separate out temperature and comfort rather than saying lower temperature ease comfort. By separating those two, we're able to achieve better air quality, better performance in terms of energy use. So when the building kind of after hours can still be used, students can hang out, we're not cooling the building, we're just keeping the fans on. So I think those are some pretty low-hanging fruits that are easy to pluck. Of course, we have relatively a lot of daylight. So it's really mitigating the daylight, but ensuring that the daylight is penetrating deep into the floor plate, so we don't need to use artificial lighting. That's another easy one to tackle.
Well, Erik, you may or may not be aware, but the location of the Kaiser Borsari building is actually in a temperate zone. Am I right, Ryan?
That's
has
correct.
very mild summers and winters. So compared to our tropical condition, they've got it easy. Tell me, Ryan.
Maybe easier.
Maybe easier.
I was going to mention that. Potentially, yes.
I mean, so Erik talked about passive design as a low-hanging fruit. To what extent was that the go-to, the first thing that you did in the design process, which is to exclude heating and cooling and electrical lighting?
Yeah, I think that's, it's interesting because we are and you don't think of that in the Pacific Northwest, but it is a fairly temperate zone. So we start to look at on all our projects, outside the technical performance, because we do have a lot of dry labs, robotics labs that are sensitive to moisture but are there other pieces of the program that you can really open up? So things like the commons areas, the ground floor lounge spaces, also I think one of the desires of students and people within the Northwest is connection to the environment. So they enjoy having the windows and the open doors and the ability to have indoor-outdoor spaces. So we really started to approach that. What are the things that we can carve off the mechanical system that we can allow those to be really take advantage of the temperate climate we live in. The other component, which Erik touched on, is really optimizing and tuning the solar gain and views and daylight within the space. So as we all know, we want to generate as much daylight, drive as deep into the project and the rooms and the spaces as possible, but you want to defeat the kind of thermal gain, right? So we don't want to overload the systems, then we have to cool to make up for that. So we spend a lot of time really optimizing where the daylight strategies, the shading strategies. On our project, we had potentially the worst orientation for one of our projects, which is a long north-south building with long edges on the east and west sides, which we all know are very hard to shade, particularly with our solar angles, which are particularly in the summertime set well into the northwest and rise well into the northeast. So we spent a lot of time looking at the windows, the configurations aligned with the program, developing shading strategies. And then one of the things which was a first for us as well was because we had the large arboretum to the east, we actually modeled the growth of the trees over generations to understand how that would impact the daylight that would be harvested by the building. So making sure that we account for that as a way to mitigate solar gain, but also long-term, can we still drive daylight into the project?
Interesting. But passive design is often, if you think about energy as a pyramid, passive design is kind of the first tier of response. Mm-hmm. What is the second tier and what is the third tier? What got harder to do, Ryan, in the quest for net zero? What then became the real challenge?
Yeah, I think, you're exactly right. Orientation of the building, the optimization of the program, all the things that really set success are kind of the things you look at first. With some campus buildings like Erik or ourselves, right, we're kind of given a site or a location or working with existing infrastructure. So sometimes those opportunities are removed. I think for us, when we start to look at the second and the third tiers for this, how do we start to reduce loads within the building? So something we can control. So working with the client, the kind of end users, the engineers, the professors who are going to use the building to talk about the reduction in plug loads, the reduction in loads overall within the building is a really important step in kind of negotiating that component, particularly in lab buildings. That's one of the highest drivers within the energy use for that. The second was kind of negotiating with the air exchanges, the air rates within the building. And once again, being a lab building, so kind of reducing the loads and the kind of demands designs within the building. And then I'd say kind of the top tier is starting to look at then positive energy generation. So on a building like this, challenges are roof area, the roof exposure. When we start to look at photovoltaics, we looked at a number of different energy generation on site. We looked at additional solar and vertical surfaces. We looked at different arrays of potential wind turbines, and we found the kind of simple ballasted photovoltaic array was the most economical and generated the most energy. So we spent a lot of time then looking at solar angles, optimizing the tilt, and then looking at not just our building, but for future expansion, are there other buildings we could couple with this to use their roofs as well?
What does net zero energy mean to the everyday life of the building? I mean, we talked about the user experience and user loads, plug loads, and so on. Does it dictate a certain compliance of behavior? And if it does, who polices that behavior? Especially students who sort of come and go, as it were. They're not, they are users, but they're not permanent users. Erik, how do you manage the use of the building through design?
Yeah, I think that's a great question. And I think it's a continuous, it requires continuous effort. But back to my first point, which is that kind of shift of culture that is required. Ryan was mentioning plug loads. A really heavy plug load user are vending machines, right? Which students love and they want them everywhere. They want to be able to grab their drink or whatever it is as quickly as possible. But actually, they're really horrible because they're little micro refrigerators. They're very inefficient. So not allowing those around and getting students to walk the extra, 50 meters to go into the canteen is something that, initially requires a certain amount of, pushback from student groups and whatnot. But I think when they're at the table, when we're communicating those values, the larger values around decarbonization and being effective with the energy budget that is there, students get on board. So the first, that's an easy one. I think some of the challenging ones at Yusof Ishak House, because it was an existing building, the orientation was set, and it was really about the kind of different programs that were being included in the building. A lot of them required some kind of acupuncture around air conditioning, whether there were kind of gym-like spaces or dance studios where students were relaxing. So kind of carefully making sure that those would group together to kind of build almost a kind of thermal zone that was air conditioned, while other spaces could be hybrid, cooled, or naturally ventilated. So there was a certain kind of planning logic around air conditioning rather than just about kind of proximity and adjacency, like we might have, what I might have taught a student, 30 years ago, that it was really proximity now is also in relationship to their air environment or their thermal environment. Another challenge we had was we have a large canteen. And this, I think, is still an ongoing one. And the way food is produced in this part of the world often requires natural gas, kind of high heat, kind of managing that, working with the vendors who come in and rent the spaces, managing all of that kind of energy ecosystem is an ongoing challenge. What we've done, and I think this has been really helpful, we've had a on-site energy manager. He's an engineer. He's really worked closely. Nirmal, you know him very well. Worked closely at the Department of Architecture buildings and helped manage that. And he's also working closely with the Yusof Ishak team to kind of just watch over things and make sure things don't go astray. And they can very easily go astray because I think the university wants to support our students and also empower them. But sometimes, when they're wanting McDonald's in the Yusof Ishak House, maybe we need to say, hey, wait a second, is that the right energy budget? Is it also the right kind of health food product that you want to be centering as an important building on campus? So it requires a lot of, talking and conversations to get people on board and aligned appropriately.
So that's the misconception about any kind of high-performing building, isn't it? That you think when you've put all the pieces in place, you're pretty much done. But it is a continuous struggle. It is something that you have to manage day to day. But for that to work, you've got to get the perspective and the representation of users and facility managers at the drawing board. If you don't bring them in early enough, then all good intentions go to waste. Ryan, who represented users and facility managers at the drawing board in your project?
I think the thing that we were very lucky on this project is that we had not only the kind of leadership of the different departments for electrical engineering, computer science, the new kind of energy studies program, but we actually had the faculty that was going to be in the building involved. And I think that's something, and it wasn't all the faculty, but it was a clear representative group so that they could talk about the spaces, how the spaces were going to be used, and then get alignment with them in terms of how those spaces and the building overall was going to perform. We also had the benefit of being able to visit the spaces. They were in adjacent buildings to see the kind of how their spaces were working and be able to try to bridge the gap. So it wouldn't be too dissimilar in terms of the new lab and new teaching space that we would be providing, with the exception being introducing daylight. Many of their spaces, they didn't have access to daylight. These were kind of buried lab spaces where, they worked very well from a technical point of view, but they weren't connected to the environment, to the outdoors. So the ability to really think about changing that and how that's going to improve not only the teaching, but the learning of the students within. And then another component is the facilities group. We had experience working on the campus on a prior project, so we were familiar with the group. But this was a very different type of project. So being able to incorporate them early, as I mentioned, in the process, engage them, and start to work with them on the design of the systems is really, I think, critical to the success of this type of project, and was something that we benefited from, that familiarity as well as being able to incorporate them earlier.
I think there's also a question of trust, right, Ryan? Like
Correct.
When you're working with people
Absolutely.
that at least there's all of a sudden we have a kind of common conversation. There's a certain amount of trust. They probably know what are the priorities that you bring to the table, and you already kind of anticipate the priorities that they have. And I think that that's important to be able to build that over time, and rather than constantly having new relationships. When you have a kind of continuous relationship, it really builds a kind of performance, I would say, in the end.
But a university is a place for constant renewal of relationships. I mean, no student body ever sticks around for more than a few years.
Hopefully.
Hopefully.
That would be doing our job properly. That they're graduating.
How do you deal with that, though? I mean, I can imagine you might well have student representation at the drawing board and get, incorporate some of their views, but it doesn't stop at that. I mean, you have to deal with, in 4 years, a completely different cohort of students who know nothing about what was discussed or decided. How do you manage that continuity?
I think when I was referring to trust, I wasn't necessarily referring just to students, because you're right, they're constantly cycling in and out. And also I think student values change relatively quickly. And that's, what's exciting about, being at a university is that change. I think what I'm referring more to is the facilities managers, the project managers, the kind of in-house team that delivers these types of buildings for the campus and looks after the aspirations of the campus. I think that that's an important relationship that needs to be cultivated and maintained to really get alignment and alignment of aspiration. And I think that that's one of the biggest challenges, which is there might be certain aspirations at the president or board of trustees level, but how that percolates down to the maintenance team, right, or the cleaning team, and to get that full kind of cross-section of the university, and to build the trust that we're all in this together and we're all trying to improve and build a more robust, resilient, decarbonized campus. That requires just like the energy manager, it requires constant kind of upkeep of an important relationship.
Ryan, in the report that your team submitted, there is explicit mention of advanced battery technology. In fact, the jury in their comments noted your unique approach to hosting energy storage. Talk me through this. What is advanced or unique about your system, and how is it better than energy storage systems that are available in the market?
Yeah, so the system, and we're still working through the finer details, is a proprietary system that was donated by a company. It's a kind of a large lithium-ion array. But I think these kind of the BESS or battery energy storage systems differ from traditional batteries in terms of that they're supplying a much larger portion of the load of the building. And there are kind of three ways that we kind of think about this within the project. The one is it can provide kind of, essentially balance the kind of loads on the electrical grid so that we have projects in Southern California where there are brownouts and other challenges with the grid and the supply of the energy. So they can help kind of temper the edges of kind of the grid and the grid demand. The other is you can bank energy using these systems for that so that you can start to bank that, to reduce the rates in terms of the consumption. The way we thought about it is, lab buildings and the research being done are critical for these type of projects and have continuous power within this. We have our large kind of solar array, and solar and wind are the primary energy generation for the campus. They are the energy generation. But for our project, we were really interested in kind of the backup. How is backup power generated on this? So our system is designed to supply not just a few hours as a typical fossil fuel generator would be, but for up to 10 days of power for the building. Now it's limited to critical systems, but it was really about supporting the research in terms of that can be stored within the building, as well as also providing the minimal kind of mechanical systems to keep the building habitable and preserved, as well as the emergency kind of egress system and lighting. So I think that's one of the differences, right? It's not just about tempering grid or kind of providing, reducing your cost, but it's really about kind of life safety and really thinking about resiliency. So think about other things that could be said, kind of events, seismic, other components, that could bring this down. How do we preserve not just the safety of the people, but also the research embodied within?
So does that mean that it's got a bigger storage capacity? Is that the big differentiating factor, that 10 days you said that so you could go off grid for 10 days and the battery system would. And is this a new battery system? Is it a new technology, or is it just an expanded version of an existing technology?
I think it's primarily an expanded version. I think the one difference is that we also have our kind of solar array, the photovoltaics. So we have an ability to kind of recharge that. So the 10 days is the design kind of load. But as we think about potentially the time of the year that this is happening, we may have the potential to extend that beyond, because we are going to be positively kind of charging that system with our photovoltaic array.
Right. Erik, in your submission and earlier in this discussion, you talked about the innovative hybrid cooling system. Talk me through this. Tell me, what is a hybrid cooling system and how is it better than a conventional cooling system?
I think it begins, if we look at it from the kind of widest, let's say, range, it begins on a few important principles. The first is that a leaky building is okay, which kind of goes against conventional wisdom. The second one is that a little sweat is okay, at least at first, right? So as I mentioned, where it's relatively high operating temperature, it uses fans to accelerate the air. We dehumidify the outdoor air environment a little bit, but it's 100% fresh air, so there's no return air on the system. So in a way, the building is kind of, if you can imagine being in a hybrid system space, it's a little bit overpressurized, and the air then leaks through, whether it's through doors or we have certain kind of plenum vents that allows the air to move, for instance, from my office out into the corridor, then it pours down into the staircase and literally out the front door. And as it's going through those different kind of spaces, it's getting warmer, but it's eventually pouring all of it out. So it's putting the kind of cool the dehumidified air, 27 degrees where it's needed, which is above my head, right here in the room that I'm in right now. It goes out into the corridor. It's getting a little bit warmer. Going into the staircase, getting a little bit warmer, and out the door. So because it's 100% fresh air, there's really low CO2 levels, no VOCs. So it's a really much better air quality than what we're kind of used to in air conditioning environments in this part of the world. I think also, and I come back to the metabolism issue, is that a lot of our students, our faculty, whether they're coming by bus or train or car, might come out of an air-conditioned environment and they walk up a bunch of flight of stairs to get to where they need to be. Historically, they thought, well, they wanted 18 degrees because they wanted to get cooled immediately. And back to the cultural change, which we've been able to achieve over many buildings now, that we just say, hey, wait a second, let your body, your metabolism just settle down, give yourself 10 minutes and you're going to be okay. And once people kind of got that, it's been wonderful. I mean, definitely in the School of Design and Environment, now the College of Design and Engineering buildings. I think for YIH or Yusof Ishak House, the test will be now it's for a building with all the kind of students and faculty that aren't just on the design side of education. So the promise is that we'll be able to convince them too that this is the right way forward. So fingers crossed.
Right. So just to clarify then, the hybrid cooling system is a modification of a conventional air conditioning system in that it combines tempered air, cooled air with a ceiling fan. Is that right? That it accelerates airspeed and therefore your perceived temperature is equivalent to that of an air-conditioned space, but with, half the energy load? Is that about right?
That's right. About half the energy load. And I think the important thing is back to the no return air. So if you imagine yourself, you're a student in a lecture theater and it felt like it was getting a little stuffy and you want to go turn down the temperature to bring more air conditioning into it, it's largely because of the CO2 level. The CO2 level was increasing because everybody's in there.
Right.
And then you get sleepy and your ink spills out on your paper or whatever as you're taking notes. So producing that better air environment where the CO2 level is as good as outside, I think is really an important characteristic of it. So it's not just a temperature and comfort, it's also just better air.
Right. Now, at the very start, I talked about the idea of walking the talk. So tell me, how does your building communicate? How will students or visitors know what has been achieved by the building that way? They're attending a lecture or buying lunch. How will they know how it performs differently from other buildings? Ryan?
Well, I think that's one of the real benefits of having the kind of Institute for Energy Studies within the building, right? So that the building in many ways is, we think of as an educational tool, kind of, and in that case, overtly, right? They're tracking and studying the energy, how the building's performing, and they're going to be monitoring that as part of their kind of educational process. We also want the building to be, that's for a very specialized student who's in the building. We also want it to be enjoyable. We want the building to be, there'll be moments within this where they connect with the building in terms of its materiality. So think of the use of mass timber, and you can look at the Arboretum beside us where, theoretically the kind of cousins of the timber within the building, because it's all harvested regionally, are right there. And we also want to have the building have these kind of teaching moments, whether it's outside, how we deal with kind of site water, the rain gardens, the kind of biophilia and kind of local plantings embedded around the site and the building, but also inside. So exposing the mechanical systems, the structural systems, the bones. That's something I appreciated with Erik's proposal is also, exposing how the building, how it's made, or what made the building, I think is really critical because it is then a learning environment. We hope, as students sit in the kind of multicultural lounge or these collaboration spaces, or hopefully they're paying attention in the labs, but if they have a moment, that they can kind of enjoy and think about how this building's constructed. And I think pose those questions, how does it achieve these kind of carbon and energy goals?
I mean, Erik and I worked on the zero energy building at the Department of Architecture at the College of Design and Engineering, and we're surrounded by architects and engineers. It's not difficult to construct teaching moments. But Erik, when you don't have architects and engineers using the building, where it's the student body at large, how do you create teaching moments at the Yusof Ishak House? How do people, visitors, users, students in particular, walk away from that aha moment, like, okay, this is a different building. It has something to do with where we are in this moment in time, which is the climate crisis. How do you convey that?
Yeah, I think it's an important question. And I think it comes back to performance, the question of performance. So the building has net zero energy targets. It's going to perform quantitatively a lot better. It will be aligned to some of the other buildings on campus that we've had the privilege to work on. But my hope is that the building also is performing in terms of its architecture. It's like a great place where students want to come and hang out, where they want to meet other professors or their friends, and they're in those spaces and say, hey, this feels good. I want to keep studying here. I want to go to my dance class. I want to meet other students. And it becomes the kind of social heart for the campus. And almost all that energy performance is in the background. Like, it just is a good building. And they're happy to be there. And if that can be achieved and being net zero, then it sets a kind of standard that all other buildings have to be like this. And then it kind of starts to build the culture in students that when they go out into the workforce, they demand similar kind of quality in the spaces that they work in, where they live, where they go shopping, etc. So that's the kind of aspiration. My fingers are crossed that we are able to pull it off. But it's really to deliver the kind of performance around all the energy issues and decarbonization issues, but also around the performance of being a good campus building, which is ultimately about the kind of social gathering and social interaction, which we know after going through the pandemic is so critical to having a good university. So that's the promise of the project. All the other things that Ryan mentioned about displaying its systems and its structure and its quality are all there, but I hope that it almost just is absorbed almost osmotically into the students.
So a well-performing building is one that doesn't display its performance. You just feel it. It feels right for where you are and what you have to do. How much more does this cost to deliver than a conventional building, or even a high-performing building, a LEED or a Green Mark certified platinum building? How much more does this cost? And it's one thing to make an argument to an owner-occupied building, especially an institute of higher learning. The real question here is, what do you take from this to your other clients, to the ones who are much more speculative in nature? Do we have an economic argument for net zero energy buildings yet?
I think it's interesting. I would say, in many ways, university projects and the universities are test bed of ideas and ways to test kind of these systems because they are purpose built and they have, very aspirational kind of goals. With that, one of the things that we've incorporated in this is I think of this projecting onto other markets or other types of projects we do, So thinking about the early energy modeling, we have very high performance required by code within Seattle and Washington State and on the West Coast. So incorporating those early in the process, but which is not uncommon, but it's something we're really looking at, innovation in terms around solar, incorporate that into projects, other renewables. So I think that's something that is something we're looking at for all our projects. And then also, most importantly, looking at the carbon of the project. So we now, whether the clients ask us to directly or not, we actually analyze internally. As if we do a design charrette, we look at the carbon of the project. So how is it embodied within this? What's the operational carbon? What are the ways to mitigate that? Or another way is thinking about it, if you were designing this, you design it to code for life safety. In many ways, can we just do that in terms of the sustainability? we should be looking at the carbon, the energy, the kind of the baseline performance of that. So we're starting to adapt those strategies, even for speculative markets, to bring the ideas to the table, not necessarily ask permission to show this, but to bring that to the table from day one. And in terms of the cost, I think these buildings, our building was delivered with a very tight budget. It was, I'm guessing, probably 15% higher than a similar kind of LEED Gold, LEED Platinum project. We were able to trade those systems off, some with donations, others, as Erik had talked a little bit about, reusing building stock. So we actually have a bridge that connects us to an existing lab building. We repurposed some of the existing office spaces to help drive the budget down for that piece, so we could spend the budget on other components. So I think being smart about where the dollars are, but these buildings are achievable for kind of traditional building budgets. I think that's the good news.
Erik, I read somewhere it was 10% higher for Yusof Ishak.
I would say, about 10%, probably closer to 6 to 7%. The ROI, return on investment, is, you could basically pay it off, at least on some of our other buildings where we're running positive, in 6, 7, 8 years. So can be done. I think universities, back to Ryan's point, university buildings are kind of unique. Both of the projects, 4 or 5 stories, have relatively large roofs. So it's a great kind of typology which to experiment and really push the envelope and kind of set a standard. When that gets into larger buildings that have, are much taller, it's a different kind of concern there. Often they're more developmentally driven. But I think we can kind of offload a lot of the knowledge and expertise that is developed on campus buildings and help really make change into all the other kind of typologies that drive a city. I have hope. I think the financial markets are already starting to shift. I have colleagues who, buy and sell buildings in terms of investment funds, and they say they won't touch a building, buying it or selling it, if they don't have an ESG plan or have a kind of a strategy for decarbonization, because the big investment, whether it's CalPERS or Temasek or different funds around the world, are driving it. So I think it's, behooves us, just as Ryan's suggesting, to get in front of the curve on operational carbon. For buildings, at least in this part of the world, it's relatively, I think for low 4 or 5 stories, can be done relatively easily. Now the big question is on the embodied carbon. How do we really drive that down? And if we can get, ahead of that curve, I think we'll have a huge transformational impact on the built environment.
Brilliant. Well, that's all the time we have today. With that, I want to thank you both for your time. It's been a pleasure talking with you.
Great.
Thanks for having me.
A big thank you to the sponsor of this series, the Holcim Foundation for Sustainable Construction. The foundation is a leading organization whose sole mission is to promote new ways of thinking and acting in the design construction sector globally. Their goal is to give you the resources you need to craft your own journey and make that journey a little easier. To learn more about the winning projects discussed in today's webinar, plus who else will be featured in this series, go to holcimfoundation.org. Thanks, everyone. Until next time, this is Nirmal Krishnani signing off in Singapore.